Good afternoon. Let us solve the second type of problem. So in this particular type of problem, they have given us sigma x, sigma y, sigma z, tau xy, tau yz, tau zx, and then the body force components also. Here they have given us the values of all the stresses, be it the normal stress or shear stress or body forces. Now please see here, they have asked us to check if the equilibrium conditions are satisfied. Okay, so what are we supposed to do is, again, write down the equations of equilibrium first. Equations of equilibrium. So that comes out to dou sigma x by dou x plus dou tau yx by dou y plus dou tau zx by dou z plus the body force component of x equals 0. Similarly, dou tau xy by dou x plus dou sigma y by dou y plus dou tau zy by dou z plus body force component of y equals 0. Then dou tau xz by dou x plus dou tau yz by dou y plus dou sigma z by dou z plus z equals 0. So these are the equations of equilibrium. Next, what are we supposed to do? They have given us that sigma x is 3xy, sigma y is 0, sigma z is 0, tau xy is 5y square, tau yz is 2z, then tau zx is 0, body force components x is minus 13y, y is 0, z is 0. If we can see, for the first equation we have dou sigma x by dou x. Let us differentiate this with respect to x. Dou sigma x by dou x equals 3y. Then you have dou tau yx by dou y. So this one has to be differentiated with respect to y. Let us differentiate it. Dou tau xy and yx are one and the same. Okay, divided by dou y equals 5 into 2, 10, 10 times y. Okay, now the third one we have dou tau zx by dou z, and you see here tau zx is 0. So dou tau zx by dou z is equal to 0. You have x value is minus 13y. I am going to substitute all of this. Say I am going to call this as equation 1 and the value of x into equation 1. So it comes out to be 3y plus 10y plus 0 minus 13y equals 0. 3y plus 10y minus 13y gets cancelled out. So 0 equals to 0. Hence, this equation is satisfied. First equation is satisfied. Okay. Next, for the second equation, dou tau xy by dou x. Tau xy is equal to 5y square should be differentiated with respect to x. Dou tau xy by dou x. This is nothing but dou by dou x of 5y square. We do not have an x component, hence 0. Then dou sigma y by dou y, that is 0. I can directly write it as dou sigma y by dou y equals 0. Then dou tau zy by dou z. I have tau yz, so this is the one. Dou tau zy by dou z, that is dou by dou z of, what is the value over here? 2z. That is going to be 2. Let us substitute all of this along with the body force component of y being 0 into the second equation. So it's going to be 0 plus 0 plus 2 plus 0 equals 0. This is how it is going to be once you substitute it. Here you can see that 2 equals to 0. That is what we are going to get. Hence, not satisfied. Okay. After every equation we need to write this, whether it is satisfied or not satisfied. Now considering the last one, that is dou tau xz by dou x. Dou tau xz is 0. I'll just write it off over here itself. Dou tau xz by dou x is 0. Dou tau yz, there is no y component over here, so it is going to be dou tau yz by dou y equals 0. Dou sigma z by dou z, sigma z is also 0. So again this is going to be 0 and z is also 0. So 0 equals 0, equation satisfied. We have first equation is satisfied and third equation is satisfied, whereas second equation is not satisfied. So at the end you need to write a comment. Therefore the equation of equilibrium is not satisfied for the given or above, anything can be written, stress distribution. Even if one equation of equilibrium is not satisfied, then it is not satisfied. Here this is the last comment that has to be written. This is the last conclusion. Only if all the three equations of equilibrium are satisfied, you need to mention that it is satisfied, else it is not satisfied.